Hi friends, Namaste. Welcome to our channel Vignan Junior College. Please subscribe this channel. Okay, in the last class already we completed both velocity and speed. In that we observed average velocity, average speed and also uniform motion. Now what is meant by the uniform motion? When a body traveling along the same straight line, if it covers equal displacements in equal intervals of time, then we can say that that body is in uniform motion. Also we completed instantaneous speed and instantaneous velocity. We discussed them with the help of position time graph. Now what is meant by instantaneous speed? The speed of a particle at a particular instant. What is meant by instantaneous velocity? Velocity of a particle at a particular instant. How to calculate them with the help of the graph? Yes, that is slope of tangent drawn to the position time graph indicates instantaneous speed or instantaneous velocity. Now, under what condition instantaneous speed is equal to average velocity or average speed? I am sorry. At what conditions instantaneous speed is equal to average speed? Yes, when the body moving with uniform speed, then instantaneous speed is equal to average speed. Instantaneous velocity is equal to average velocity only when body moving with uniform velocity, that is body in uniform motion. Now today I want to discuss some applications on average speed and average velocity. Actually, what is this chapter? Motion in a straight line. That means when the body moving along the same straight line, we can say that its average velocity, that is magnitude of average velocity, is equal to average speed, and at the same time magnitude of instantaneous velocity is equal to instantaneous speed. Remember that in this chapter we discuss only body moving along the same straight line. Remember that. Listen to me. Okay, I want to discuss this application here. Observe this. When a body travels a distance s1, s2, so on up to sn in respective time intervals t1, t2, so on up to tn, then its average speed and average velocity are. That means we are going to calculate its average speed and average velocity. Going to calculate average speed and average velocity. Does these two are equal or not here? Yes, these two are equal. Why? Here body moving along the same straight line. So these two are equal. That means here we are going to calculate any one of them, either average velocity or average speed. Remember that. Now observe that problem. A particle moving along the same straight line and it covers the distances or positions or displacements in this manner. Here it is s1, s2, so on, and s3, so on, sn in respective time intervals t1, t2, t3, so on up to tn. t1, t2, t3, so on up to tn. Now we are going to calculate average speed. Tell me, what is the formula for the average speed? Average speed. Give me the formula for the average speed. that is total distance travelled by the particle. Actually, it is total length of the path travelled by the particle divided by total time taken. Now, here, what is the total distance travelled by the particle? Yes, S1 plus S2 plus S3 plus so on up to Sn. S1 plus S2 plus so on Sn divided by time interval, total time interval. Now, for this complete journey, here time interval is T1 plus T2 plus so on Tn. This is the answer, very simple one. That is total displacement divided by total time interval, that is average velocity. Both are same or not? Average speed and average velocity. Yes, both are equal. Why? Because particle moving along the same straight line. Remember that. Now observe this again. Particle moving along the same straight line. It covers the distances S1, S2, S3 so on up to Sn in respective time intervals T1, T2, T3 so on up to Tn. Now, what is the formula for it? Average speed formula. Average speed formula, total displacement divided by total time taken. Total displacement divided by total time taken, nothing but average velocity. Now, average speed nothing but actual length of the path. We can also say it as distance. We can also say it as total distance. Total distance. Now, you tell me what is total distance covered by the particle here? S1 plus S2 plus S3 plus so on up to Sn. Now, what is total time taken? Yes, T1 plus T2 plus T3 plus so on up to Tn. Okay. That is this one, S1 plus S2 plus S3 plus so on up to Sn divided by T1 plus T2 plus T3 plus so on up to Tn. Okay. Now, I am going to discuss another application here. Observe this. When a body travels with different speeds v1, v2, so on up to vn in time intervals of t1, t2, so on up to tn, then its average speed, we are going to calculate its average speed, whether it is equal to average velocity or not. Yes, in magnitude, average velocity is equal to average speed. Why? Because particle moving along the same straight line. Remember that. Now, here I want to calculate average speed. Body travels along the same straight line with different speeds v1, v2, v3, so up to vn. In the time interval t1, its speed v1. In time interval t2, its speed v2. So on. In the time interval Tn, its speed Vn. Now, we are going to calculate its average speed. First, you tell me the definition for average speed. What is the definition for average speed? Yes, total length of the path travelled by the particle divided by total time taken, or total distance travelled by the particle divided by total time taken. Now, here total length of the path travelled by the particle. Here it was not given. Here in the problem they are given that speeds and time intervals. Okay, in this time interval t1, I am assuming that distance travelled by the particle is s1. During the time interval t2, it is s2. So on, during the time interval tn, it is sn. So, s1 plus s2 plus so on sn divided by total time interval t1 plus t2 plus so on tn. Now this is equal to, what is S1? Distance travelled by the particle in t1 seconds with average speed v1. Already you know that average speed is equal to distance divided by time. Therefore, distance is equal to average speed into time interval. So, instead of S1, I want to use V1 into T1. V is equal to S divided by T, total distance travelled by the particle divided by time interval. So, S is equal to how much? V into T. This formula I want to use here. That is average velocity into time interval. During the time interval t1, its average velocity is v1. Therefore, instead of s1, it is v1 into t1 plus, instead of s2, v2 into t2 plus so on vn into tn. Sn nothing but vn into tn divided by total time interval t1 plus t2 plus so on tn. This is the answer. It is also very simple. Here also we used the formula, that is the definition for average speed. That is, by using that definition we derived this one, v1 t1 plus v2 t2 plus so on up to vn tn divided by total time interval. Remember that. Observe once again it. Particle moving along the same straight line. During the time intervals t1, t2, so on up to tn, respective velocities are, or respective speeds are v1, v2, so on up to vn. Now, during those time intervals, displacements or distances or path lengths are s1, s2, so on up to sn. Now, what is the formula for average speed? Total path length travelled by a body divided by time taken, that is total time interval. Now, this is the answer, s1 plus s2 plus so on up to sn. Instead of s, what we used? V into t, because path length is equal to average speed into time interval, or displacement is equal to average velocity into time interval. By using that formula, instead of s1, v1 t1, s2, v2 t2, sn, vn tn. Remember that. Now, next application, this one. Before going to this application, I want to ask one question. Once again, I want to ask one question. Under what condition average velocity is equal to instantaneous velocity? Recall this, because it is an important one. Under what condition average velocity is equal to instantaneous velocity? Yes, it is in case of uniform motion. Okay, in case of uniform motion. Okay. Now you observe this application. A body travels first half of total time with speed v1 and remaining half interval with speed v2, then its average velocity. We are going to calculate its average velocity. Okay, for that also I want to draw a diagram. Here also body moving along the same straight line. When a body moving along the same straight line, in first half of total time interval, I want to consider this. Totally I want to consider the time interval is t seconds. During the first half, nothing but in t by 2 seconds, it moving with the speed v1, and in the next half time interval, its speed v2, its speed v2. Now during this time interval t by 2 seconds, first t by 2 seconds, what is the displacement covered by it, or what is the path length covered by it? Yes, I want to assume s1. Here it is s2. Now we are going to calculate average velocity. Here average velocity is equal to, tell me what is the definition? Total displacement covered by the particle divided by total time interval. Now what is the total displacement covered by the particle for this journey? S1 plus S2. It is S1 plus S2 divided by time interval t by 2 seconds plus t by 2 seconds. But in the problem they are not given S1 and S2, they are given that V1 and V2. So instead of S1, I want to use the formula average velocity into time interval, nothing but V1 into t by 2. S2 means V2 into t by 2, V2 into t by 2. Now you substitute these two in this expression. It is V1 into t by 2 plus V2 into t by 2 divided by t by 2 plus t by 2, nothing but t. Now it is equal to V1 plus V2 into t by 2 divided by t. Now this t gets cancelled, then average velocity is equal to V1 plus V2 divided by 2. Average velocity is equal to V1 plus V2 divided by 2. That is, it is also depending upon the definition. You must remember the definitions of both average velocity and average speed. Okay. Now observe that problem once again here. That is, in first t by 2 seconds, velocity of the particle v1. In next t by 2 seconds, velocity of the particle v2. During this time interval t by 2 seconds, displacement s1, and in t by 2 seconds, I want to consider displacement as s2. Now average velocity means displacement of a body divided by time taken. Now on substituting the values, finally you will get the answer as v1 plus v2 divided by 2. Okay. Now next one. Before going to this application, I am asking again one question. What is the definition for a displacement? Do you remember it? Is it the shortest distance traveled by the particle? Is it the shortest distance traveled by the particle? No, it is not the correct one. What is the correct definition for the displacement? It is the difference between final position and initial position. Displacement nothing but the difference between final position and initial position. Remember that definition. Don't say it is the shortest path traveled by the particle or the shortest distance traveled by the particle. It fails in some cases. Already we observed that example in the first class. Remember that displacement nothing but difference between final and initial positions of the path traveled by the particle. Okay. Now observe this application. When a body covers distances S1, S2, so on up to Sn with different speeds V1, V2, V3, so on up to Vn respectively, then its average speed we are going to calculate. We are going to calculate its average speed. Now, body covers distances S1, S2, so on up to Sn. I want to consider here also particle moving along same straight line. Now, during this displacement S1, its speed V1. During the displacement S2, its speed V2. So on, during the displacement Sn, its speed Vn. Now, which one you want to calculate? Average speed. Here in this application also body moving along the same straight line. So, here average speed is equal to magnitude of average velocity. Is it true or not? Yes. That is average magnitude of average velocity is equal to average speed when the body moving along the same straight line. Okay. Now we are going to calculate average speed. Simple one it also. Tell me the definition for average speed. Total path length traveled by the particle. Now in this, total length of the path S1 plus S2 plus so on Sn divided by total time interval. I want to consider for this displacement S1, it takes the time t1 seconds. For the displacement to cover this displacement or to cover this path length S2, time interval is t2. To cover this displacement or path length, time interval tn. Here path length and magnitude of displacements are equal because particle moving along same straight line. Remember that. Whole divided by t1 plus t2 plus so on tn. Now, what is t1, t2 and so on up to tn? Does they are given in the problem? No. Now, I want to use the formula. Distance traveled by the particle is equal to average velocity into time interval. So, t nothing but s divided by v. T nothing but s divided by v. Now, you tell me what is t1 for this part. What is t1? s1 divided by v1. S by v. So, it is s1 by v1. Now, you substitute it. S1 plus S2 plus so on Sn whole divided by, instead of T1, S1 divided by V1, T2, observe this, S2 divided by V2, S2 divided by V2 plus so on Sn divided by Vn. That's enough. We calculated that average speed in terms of S and V. It is also very simple. Observe that once again. What is average speed? Total path length travelled by a body divided by time taken. Here, during this journey, time interval t1, during this journey time interval t2, for this journey t3, so on for this journey time interval tn. Now here t is equal to distance travelled by the particle divided by average velocity, or sorry, average speed. Here I am saying distance, so it is average speed. Now by using that formula we solved that. This is the final answer. Observe that. Okay. Now, next application, observe this. Before going to this, once again I am asking one question. What is meant by reference frame? Frame of reference. That is a three-dimensional coordinate system along with a clock. We called it as a reference frame. That means your room, that is corner of your room along with wall clock, you will consider it as a reference frame. Okay. Already we discussed it in first class. Next, now you observe this application. When a body covers first half of the distance with speed v1 and the remaining half distance with speed v2, then average speed is. Here also I want to consider particle moving along the same straight line. In all these applications, I want to consider particle moving along same straight line. Okay, I want to solve this. Here, particle moving along same straight line, or body moving along same straight line, or car moving along the same straight line. Now, first half of the total distance, I want to consider the total distance travelled by this particle is equal to s. First half of the total distance, nothing but s by 2. This covered with the speed v1. Second half of the distance covered with the speed v2. Now we are going to calculate average speed. Once again you write the definition for average speed. What is it? Total length of the path travelled by the particle divided by time taken. Okay, what is total length of the path travelled by the particle here? Tell me. It is s by 2 plus s by 2. S by 2 plus s by 2 whole divided by time interval. But in the problem it is not given. I am assuming for this journey the particle takes the time t1. For this journey it takes the time t2. Also we know that displacement s is equal to average velocity into time interval. So time interval t is equal to s divided by v. Now s by 2 plus s by 2, s divided by t1, nothing but, observe this, s by v. Instead of s here s by 2 is there, instead of v, v1 is there. So t1 can be written as s by 2 divided by v1. t2 s by 2 divided by v2, then it is equal to s divided by s by 2 v1 plus s by 2 v2. 2 v1 plus s by 2 v2, that is equal to, otherwise you will take that s by 2 as common, s divided by taking s by 2 as common, here it becomes 1 by v1 plus 1 by v2. One by v1 plus 1 by v2, then that is equal to, s gets cancelled, 2 goes to the numerator, it is 1 by v1 plus 1 by v2, LCM is V1 V2 for this. In the denominator, LCM is V1 V2. Now here it becomes V2 plus V1. Again this is equal to 2V1 V2 divided by V2 plus V1 can be written as V1 plus V2. That is the answer. It is also simple one. From the definition we derived that. Remember that. Now you observe the same thing here. During this journey, s by 2 velocity or speed is equal to v1. For this journey, speed v2. Now for this journey, time interval t1, for this journey, time interval t2. Here, what about t? T is equal to s by v. Remember that. T nothing but s by v. Displacement divided by average speed or average velocity. Remember that. Now this is the solution for it. Just you observe that. 2v1 v2 divided by v1 plus v2. Okay. Next one. Observe here. When a body travels along a straight line from A to B with a speed v1 and from B to A with a speed v2, then its average velocity and average speed. Now in this problem, is the particle travels along the same straight line? Along the same straight line or not? Yes, but its direction changes. Here, observe that. When a body travels along a straight line from A to B, first it travels from A to B, with a speed v1 in the forward direction. A to B, its a speed v1. I am assuming it covers the displacement, yes, during the time interval t1 seconds. Now, does it stops there? No. Does it moves forward? No. What happens to it? And from B to A, it wants to return back to A along the same line, but for our explanation convenience, I want to use another line here. For our explanation convenience, I want to use another path, but actually it is moving along the same path, same line. Now finally it again reached to the point A, but for this journey B to A, its velocity or its speed is v2, displacement, yes, I am assuming time interval is t2. Here these two are different, that is velocity and time intervals are different, but what about their path lengths? They are same. Path lengths are same. Now we are going to calculate first average velocity. Observe that. I want to calculate average velocity first. Tell me, what is average velocity? Displacement covered by the particle divided by time interval. Now for this journey, what is the displacement covered by the particle for this entire journey? What is the displacement covered by the particle? 0. Why? Displacement nothing but final position minus initial position. Here its final position coincides with its initial position. So displacement 0. Now what about the time interval? t1 plus t2. Then average velocity is equal to how much? 0. Now you calculate average speed here. Now you calculate this average speed. What is the definition for average speed? Total length of the path travelled by the particle divided by total time interval, total time taken. Now what is total length of the path travelled by the particle? Actual length of the path travelled by the particle, s plus s, 2s. Actual length, it is 2s divided by total time interval, that is t1 plus t2. Once again, 2s divided by, what is t1 here? S divided by v1. Already we know that the formula S is equal to v into t, average velocity into time interval. So here t is equal to s by v. So here it becomes s divided by v1. t1 means s divided by v1. t2, similarly it is s divided by v2. S divided by v2. This is s only. S divided by v2. Now on simplifying this, it becomes 2 divided by 1 by v1 plus 1 by v2. You will take s as common in the denominator. Therefore s and s gets cancelled. You will get 2 divided by 1 by v1 plus 1 by v2. Now it becomes 2 v1 v2 divided by v1 plus v2. That is, in this problem, does the average speed and average velocity are equal? No. Why? Why these two are not equal? One, it is 0 average velocity, average speed, 2 v1 v2 divided by v1 plus v2. Why these two are different? Here in this application, particle is not moving along the same straight line. Here its direction changes. So in this situation, average velocity is not equal to average speed. Remember that. Same thing, forward journey and it is backward journey. Now average speed, total path length travelled by a body divided by total time taken. Then you will get, it is 2 v1 v2 divided by v1 plus v2. Now what is about average velocity? Displacement of a body divided by time taken. Now it is equal to how much? Displacement nothing but 0. Why it is equal to 0? Because its final position coincides with initial position. So displacement means it is the final position minus initial position. So displacement is equal to 0, average velocity is equal to 0. Now I am asking one question here, is that speed is negative? In any case, is the speed is negative? No, speed always positive. What is about speed definition? Tell me. That is actual length of the path travelled by the particle divided by time interval. Total length of the path travelled by the particle divided by time interval, or distance travelled by the particle divided by time interval. We know that distance always positive. So speed also always positive. Remember that point. Speed always positive. Always positive. It never be equal to 0. Displacement never be equal to 0. Speed never be positive because path length or not displacement, it is distance. Distance never be equal to 0, that is path length never be equal to 0, it is having some value. So, speed never be equal to 0, speed never be negative because path length is not negative, it always positive. So, speed also always positive, remember that. And what about velocity? What about velocity? Now, tell me the definition for the velocity. Yes, it is displacement covered by the particle divided by time taken. Displacement may be positive, may be negative, may be equal to 0. So, velocity may be positive, may be positive, may be negative, may be equal to 0, may be 0, remember that. And also we can say that speed always greater than or equal to velocity. Already we know that path length always greater than or equal to displacement. So, here I want to write it as speed always greater than or equal to velocity. Speed always greater than or equal to velocity. Here speed, what type of the physical quantity? Is it a vector or a scalar? Yes, speed scalar. Velocity vector. What is meant by the vector? It is a physical quantity having both magnitude and direction is called a vector. Is it a vector? No. What is the definition for the vector? A physical quantity having both magnitude and direction, and also it obeys parallelogram law of vector addition. Then only we called that physical quantity as a vector. Already we know it, we discussed it in first class. Now, is that electric current is a vector or a scalar? It is having both magnitude and direction. Yes, it is a scalar. Why? Because it does not obeys the parallelogram law of vector addition. Okay. Next one. You will observe this application here. A particle starting from point A. Observe this diagram. It starts at point A, traveling up to B, with speed S. Here speed in terms of S, not in V. Remember that it is given in terms of S. From A to B, its speed S. Its speed is S. Then up to point C with a speed 2s. From B to C, its speed 2s. From C to A, that is finally up to A, nothing but C to A, with a speed 3s. Here its a speed 3s. Then find its average speed. Find its average speed. Now, how to calculate that average speed? Okay, before going to calculate that average speed, what is the definition for it? Total length of the path travelled by the particle divided by total time taken. Okay, here that time intervals are not given. I want to consider those time intervals in this manner. For this journey A to B, time interval T1. For the journey B to C, time interval T2. For the journey C to A, time interval t3, and we know that T is equal to S divided by V. We know this formula, and also we know that when a particle moving along the circumference of a circle, the displacement covered by that particle can be calculated by using the formula 2r sin theta by 2. Theta is the angle subtended by the radius, and distance travelled by the particle can be calculated by using the formula r into theta. Already we observed it in the second class, that is applications of distance and displacement. Now here, when the particle moves from A to B, tell me what is the distance travelled by the particle? Here this line joining the center to the point A, nothing but radius. This radius subtends an angle. How much angle it is? 90 degrees. That angle is equal to 90 degrees. Already we know that pi is equal to, pi is equal to how much? 180 degrees. Therefore, pi by 2 means 90 degrees. 90 degrees nothing but pi by 2. Therefore, A to B, what is the path length? A to B path length. Tell me, what is the path length? R into theta, which is A to B path length. Or displacement. I am assuming it as L1 is equal to R into theta, that is equal to R into pi by 2. Already we discussed that angle should be substitute in radians. In SI units, the unit of angle is radian. So, I want to substitute it in terms of radians, nothing but pi by 2. 90 degrees nothing but pi by 2 radians. Remember that. Now, while it travels from B to C, what is the path length? While it travels from B to C, its path length L2 is equal to, now you tell me, 120 degrees nothing but 2 pi by 3. Observe that 120 degrees nothing but 2 pi by 3. What is pi by 3? 180 divided by 3, 60 degrees. 60 into 2, 120 degrees. Pi by 3 nothing but 180 divided by 3, it is 60 degrees. Therefore, 2 pi by 3 means 120 degrees. Therefore, from B to C, its path length is R into theta, formula is same, but theta is 2 pi by 3. Remember that it is 2 pi by 3. Now, for this journey C to A, tell me the path length. Path length L3 is equal to R into theta, that is equal to R into, what is theta? Here what is theta? What is this complete angle? 360 degrees. If particle completes one revolution, that radius subtends how much angle at the center? It is 360 degrees. Now what about this angle? 90 degrees. What about this angle? 120 degrees. 90 plus 120. 360 minus 90 plus 120. 90 plus 120. How much? 210. Now 360 minus 210. It becomes 150 degrees. That angle is equal to 150 degrees. But 150 degrees is equal to, I want to say, pi by 6 is equal to how much? 30 degrees. Is it true or not? 180 divided by 6, 30 degrees. 30 into 5, 150. Therefore, it is equal to 5 pi by 3. Is it correct or not? Check yourself. Is it correct? No. Pi by 3, 60. 5 into 60, 300. Therefore, it is not pi by 3. It is 5 pi divided by 6. Pi by 6. 30 degrees into 5, 150 degrees. Remember that. Therefore, R into 5 pi divided by 6. Now we are going to calculate average speed here. Average speed, nothing but total length of the path travelled by the particle, L1 plus L2 plus L3, total length for the complete journey, divided by time interval T1 plus T2 plus T3. T1 plus T2 plus T3, that is the total time interval. Now, but we don't know T1, T2, T3. What about T1, what about T2 and what about T3? Observe this. L1, okay, L1, nothing but L1 I want to consider in the same manner, I will substitute later, divided by T1 means S divided by V. Therefore, L1 divided by V. What about velocity during the time interval? Yes, velocity is given in terms of S, remember that. Plus, tell me what about L2 for this journey? Path length L2 divided by velocity or speed 2s. So, sorry, it is not velocity, it is a speed, because the direction changes from point to point while the particle moving along the circumference of a circle. Here the particle is not moving along the same straight line, remember that. Plus L3 divided by 3s. Now you substitute the values of L1, L2, L3. That is equal to L1 means pi r divided by 2 plus L2 nothing but 2 pi r divided by 3 plus 5 pi r divided by 6 whole divided by L1 again pi r by 2 divided by s, it becomes s, plus L2 means 2 pi r divided by 3 into 2s plus L3 5 pi r divided by 6 into 3s. Now you will simplify this from here onwards. Here it is 5 pi r, remember that. Now from here onwards you will simplify it. I will not do this, you will simplify that. You will get it is equal to 1.8, yes, don't say it is second, it is 1.8 s, that is equal to 1.8 s. You will simplify that. Very simple that. Here also we followed the same formula, that is total path length divided by total time taken. But here, while the particle moving along the circumference of a circle, if its radius makes an angle theta at the center, then distance travelled by the particle can be calculated by using the formula r into theta. That formula here we used. Remember that formula. And now in this situation, tell me the average velocity. In this situation, tell me average velocity. What is the formula for average velocity? Total displacement covered by the particle divided by time taken. Here particle moves from point A and finally it reaches to that point A. Therefore, for that complete journey, velocity is equal to 0. Why? Displacement is equal to 0. For that complete journey, displacement is equal to 0. Is it true or not? That is final position minus initial position is equal to 0, because final position coincides to the initial position. So, displacement 0, therefore, its average velocity is also equal to 0. Remember that thing. That is, all these applications that we discussed depends on only definitions. Nothing is there in this. Remember that. Okay. I think time is over. I want to leave the class. I want to end this session. Please subscribe our channel. It is Vignan Junior College. Okay. Thank you.